Greetings and welcome to this episode of Let's Create Something with Trapcode TAO. Do you love mathematics? Do you salivate when you look at formulas? Do you have an ease at understanding them? Well, I know I don't, but that doesn't prevent me to have fun experimenting, play around with mathematic formulas. So today I want to share that with you. It's all going to be about knots. So we're going to learn how to create knot shapes parametrically with equations. So let's look into that. First, we're going to create a new composition, and let's make it a square one, so 1080 by 1080. And let's create a light, so Control Alt Shift L, and we're going to call this light Tau, and let's hit OK. So we just have a light here. There it is. We don't have the Tau yet. Let's figure out our path. So I was looking at that Wikipedia for that. It's called a trefoil knot, and it's kind of a cool looping shape here, and it can be drawn using this kind of an expression. But what does that mean? If you're a mathematician, well, this is really basic stuff for you. You have no trouble understanding that. But if you're more of an artistic person, this might be something of alien language. It's quite unfamiliar, but you love this. You love looking at that, and you look at that, and you don't understand right away. It's not quite obvious for someone who's more artistically oriented than mathematically oriented. So math people, don't laugh at me. I'm part of those who are more artistic, but I love to play around. So let's figure out something with something basic like that, and let's try to use our light in Tao to create this path here using and translating that into expression that After Effects can understand. So let's do that. So first, let's hit P to reveal the position of our light, and let's zero it down so it's right at the corner here on the top there. And let's make a new null here, and we're gonna make that 3D, and we're gonna link it to that. So let's zero it out on the null so it's right at the center here, while we have zeros and 0, 0 as the coordinate, and that'll be our starting point. So first, let's alt click on the stopwatch here to enable the expressions, and then we're simply gonna do something that's gonna do nothing at first. So the position is constituted of 3 values: X, Y, and Z. So it's 3 numbers that we have to put in there, and how we want to separate those when we type down an expression is by using a bracket and separating those values with a comma. So we're going to just open the bracket, and we're going to type 0, 0, 0, so that X, Y, and Z are at 0. Close that, and the semicolon to specify the end of our command line here. And that's the most basic thing, that we are now telling the coordinates via here, this text box here inside. So now the second thing that we're gonna do, that's once again gonna be useless. It's not gonna do anything visually, but we're gonna learn to define variables. So this is gonna be our X, Y, and Z. So we're gonna define that. We just have to say like X is going to be equal 0, then we put a semicolon because that specifies the end of our command line. We go to the next command line. We're going to tell Y is going to be equal to 0, semicolon, and then Z is equal to 0. So now we have specified 3 variables. Instead of writing down 0 here, we can call the value that resides in them just by typing their name. So here is going to be X, Y, and Z. So once again, we have 0, 0, 0. If I put 100 here, it's going to put 100 here. Okay, so we have a spot now where we can define our variables, and we can have equations in there. So let's type down some equations. Here is the Wikipedia page for something that's called a trefoil knot. So there we have the expression here, and we're going to try to translate that into something that After Effects understands. So right there, let's hit Windows key and left, so we have this fill the left half of our screen, and let's do the same with our browser here. So we have the formula here, x equals sin multiplied by t plus 2 times sin 2 multiplied by t. Okay, step by step. So first is sin. So sin is something that we can fetch right here. We have this little arrow here. We have the JavaScript math. So these are some equations that are pre-made for us that we can just fetch. So here is math sin. It expects a value here between the parentheses. So let's click here, and what we want to put here is t. So t is something we don't have defined yet. We want to use the time for that. Okay, so let's define a value. So let's say t is simply going to be equal to time. So that's the first thing we're going to define here. So we don't need to write down time here. We can say math sin t. Okay, but that's not all. We have to make an addition here. So let's use the plus sign here, and then it's 2 times sin of 2 multiplied by the time. So 2 times, this is the little asterisk here, it means multiplication, and once again math sin. So math sin here, let's get it at the same place, and the value of the math sin that is multiplied by 2 this time is 2 multiplied by the time. So here, instead of the word value here, we're gonna say 2 multiplied by the time. Okay, if we click outside now, it doesn't say that we have an error, so it looks that it's working for the moment. And here we have some values here, but it seems that it's really tiny of a motion for the moment. Let's figure out the y before we go and figure out what's happening exactly. So the y, let's set the second line here, and it looks about the same as the first one. There are 2 main differences. Instead of sin, it's cos, and instead of a plus here, it's a minus. So we're gonna be a little bit lazy, and we're simply gonna, here we can just write 2 times t, right? So we're gonna simply copy down this first that we got here. We're gonna paste it here, and instead of sin, it's cos. So we can just replace the word here. It's another command that exists here. We can fetch it the exact same way, and instead of the plus here, it's the minus. So I'm gonna type minus there. So this is gonna, now we have our y figured out, and then it's the z. So minus sin 3 multiplied by the time. So let's translate that. So minus sign, and then math sin, we can type it down ourselves, big boys now. So math dot sin of, now the parentheses, it expects a value in between them, and this is 3 multiplied by the time. So t, 3 multiplied by t. When they're stuck together like that, means they are multiplied. So let's click elsewhere, and then we have it all figured out. We're not seeing much now. We don't even have it applied on TAO. So we can click on here. It's show post expression graph, and it's gonna help us if we have our light selected. Let's go there, and if we zoom right really close to it, we're gonna see that we do have our shape. So the numbers are good. It's just that it's really tiny value. So we're gonna multiply all that. We can make ourselves a multiplier. So basically, what we want to do here is to multiply the x by 10, and multiply the y by 10, and multiply the z by 10. If we multiply like everything by 10, what would then happen? So let's look at that, and there, I don't have to zoom as much anymore, but it's still small. So we know that we can use that. It's definitely something that we can use to define the overall scale of our thing. So let's create a value for that. So just after the time, I'm gonna call that multiplier, or simply the scale. So we're gonna say it's let's say 100. It's not 10 but 100, and it's here just gonna multiply that by scale. So instead of 10, it's the name of the value that we've specified up there, and that we've said is equal to 100. And what do we have here? We have our shape that's getting drawn, and there. We can start to figure more things after, but let's apply that to TAO. So let's create a solid. We didn't even do that yet, so let's call it TAO. Now it's a purple one. It's the last color I used. Let's fetch our beloved effect here in the effect panel. Let's apply it on our solid, and boom, we already do have something because our light was correctly named TAO, and it's laying down some geometry as it's going around on this path. So let's go on the path generator and let's close down what's default. And here we do know that something that usually we do at first is Control Alt O on our light. We didn't do that. We didn't even turn the auto orientation off. So let's do that, and there it looks a little bit more as it's supposed to, and I figure we need to add some segments for it to look even smoother. So there, we're starting to have our trefoil nut. Let's add some sides. We want it to be a little bit more cylindrical. Here we can reduce the size of it, and it's pretty clear that we do have our kind of shape now. And let's see. Let's look at time-wise. We know that usually TAO it's using 300 frames to lay down the geometry. So let's see what's our light doing and how much time is it taking to go to where it's going. So it starts there at 0, and it's going around and it's going around, and let's see how much it takes for the loop. Like it's going back to around frame 190, and then up to 300 it's going over what's already drawn. So let's try to make it so it's closing like perfectly. And the quickest way to do that, let's go into paths from light, and instead of using 10 seconds 300 frames, we're gonna use less time. So let's bring this number down until the path is not full. So right there. So at 5 seconds it has not yet done the loop, but you can see it kind of start to close down at 6.3 right there. 6.3 is kind of the number, maybe 6.35, like to make sure that it's doesn't look like there's a seam there. And maybe you can just increase that just a little bit. And there's going to always be something unless we add many more segments. All right, so this is pretty fun. It's our basic shape, and let's help ourselves. So right now the scale is 100. I would like to get a slider to change that, and it's not quite obvious because I have to type it down manually there. So let's get on our null that we've created earlier, and let's go to effect. And I've got many effects there, but let's go into expression controls and slider controls, and let's type down 100 in there. So that's our scale value, and we're just gonna link that to that. So let's lock this down here so it doesn't get out of our view, and let's go into our text box here and select the 100 here. Just make sure that it's selected. So I've just clicked here, go at the end of the number, and then shift left arrow key to grab the number, and then I'm gonna use the pick whip and just link it over there. So once that is done, it's gonna type down something for you, and that's gonna allow us to change the scale with that. Pretty cool, eh? And there's also something else that we could do. Like this is a trefoil knot, and under there is written like, oh, the Torus knot is also a trefoil knot. The following parametric equation give a 2-3 Torus knot lying on Torus. And it's looks a little bit like the same, but it's a little bit different. So let's translate that to that. And let's see what we're gonna get out of that. It's gonna be the Torus knot. So let's duplicate our comp here, on which we have the trefoil knot. And let's go here. I'm gonna play around with our little formula here. So there. Let's toss this on the side again. It says x equals. So let's start from scratch with the x. So x equals parentheses 2 plus math.cos multiplied by 3 times the time. So we're gonna add a parentheses here. Math cos of 3 times the time, close parentheses, and that's multiplied by math. We're gonna open again math cos, open parentheses, 2 times the time, close and close. Did we make an error? Yes, we did. So let's figure out where is our error. I figure we forgot to close something. So yeah, we got 3 here and there. Okay, this is correct, I think. Let's grab that. And we're gonna copy that on the Y. And the only change here, it's still a plus, but here it's sin instead of cos. So let's paste that here, and let's just change the second one. The first one stays cos, and the second one is going to be sin. And the third thing, we don't need it to be subtracted anymore for the z, but it's still math sin 3 times the time. So let's click elsewhere, and that's what we got. So a different formula, a different kind of knot. And let's keep on the parametric things. What fun can we have? I found this nice Torus knot list here, and there are some values that we can try. If you see here, the 3 and the 2 are kind of our numbers here that we're using, like the 2 and the 3. So hey, maybe if we try to put a 5 instead, let's put some sliders so we can play around even more. So that was the scale. So let's name that scale. All right, and this is locked down. I think we've duplicated it. So let's make sure that we have the right one here. Then it's linked to that. And yeah, it's the scale. So let's have the value 1 and value 2. Value 1 is going to be 2, 3, 3, 2. So we're going to keep the order of that. It's kind of reversed with what we have, but it's going to be easier for us after the test. So where it uses 3 here, we're going to link it to that. So where is the 3? It's just once there is on the Z. Oh no, it's there as well. So each time there's the 3, let's replace the 3 with our value 1 here. And it's gonna start to look a little bit complicated in there. I know. That's why we're doing that this way. So just grab the 3, link it there on value 1, and grab the 3, select it, link it there on value 1, and then the 2, but not the 2 from null 2 here. Don't. The 2 from this 2 here. So let's grab that and let's replace it with value 2. And let's grab that 2 here and replace it with value 2. And again, that 2 here, multiplying the time at the end, also value 2 and value 2. Link them. Starting to look quite messy in there, but we don't need to understand it anymore. It's okay. It's okay. And nothing should change here, but now let's see. This is 5, 2. So instead of a 3, let's put a 5. And there we have this shape. So this kind of this shape, and if we put 7 2 7 2, you kind of get this shape. 4 3 4 3. Let's try that. Oh, maybe it's not exactly the same. And this is the kind of knot that we have now. It doesn't look quite exactly the same. Perhaps I'm not doing this exactly right, but you, if you know maths, you can perhaps show me what I'm doing wrong here. Let's try this one. 5 3, and that's pretty good shape. And there is still we can play around with the scale there. So pretty cool. 5 4. Let's try a 4 there, or a 2. And so that's it for the principle. And once that's figured out, I mean, there's many things that you can do with that. Let's color it. So let's start with red, and now it's around frame 190, around that. So let's make sure it's still red, and I've created a keyframe. It's going to be red, and right in the middle, let's say it's going to be blue. So we have some kind of a shift in color here. And let's get to the TAO effect, and let's play around with our offset. So nothing really complicated here. I'm going to go in offset here, and instead of the size here, I'm going to uncheck that, and there is the offset color TAO lights. I'm going to check that in, and that means that we can offset the color if we drag this. But here it's not going to be looping. We can check this for it to loop. So we're not going to have a weird spot where it cuts now. We can animate that. So let's make it 45 frames. Let's create a keyframe on the offset at frame 0. Go to frame 45. And let's set that to 100. And let's go one frame prior, frame 44. And we're going to run that to see it go really animated loop. And let's enhance the look of that a little bit. So I'm going to make it a little background there. Let's make it kind of purplish blue there, or maybe something else. Let's try that. Or maybe a little bit darker and a little bit more purple. Let's set the rendering mode on to smooth. And also, let's get in the segments, and as little as we have here for the size. This is 4 sides, 5 sides. You can shut off the chamfer here, and yeah, if we uncheck break the sides, even if we have only 5 sides, see how it's gonna be smooth, and it's not gonna take a lot of time to calculate. So this might be something that you can think about. And we can also reduce, I think, the amount of segments up to a certain point, because if we go too low, then it's gonna start to look like that. And maybe if we go too low as well, we're gonna start to see a seam somewhere. But there, it's kind of easy for us to create that. And we can also increase the ambient occlusion. Doesn't seem to look so good on that. And let's leave it at default. I guess for that we would need the sides to be more size, and uncheck, make sure that break size is unchecked. And now let's, yeah, so we can get best shadow if the sides are actually up. But if we don't need the shadows, then that's pretty fine. It's gonna be a little bit of grains in there, but try to find the numbers that are best for the type of thing we're looking for, and everything should be okay after from this point. We can also use some built-in image-based lighting. That was the word I was searching. So let's try the graffiti ruin. Oh, that's perhaps a little bit too much diffusion. We're kind of losing the color here, or maybe we need more diffuse strength but less reflection. I don't know if you like that much, but cancel it with the Fresnel. It's not gonna cancel it equally depending on if the surface of the geometry is facing the camera or not. So that's kind of a nice look here that we got, and we can mix that with lights. So let's get here and activate TAO Lumi lights, and let's create a Control-Alt-Shift-L. Let's make ourselves an ambient light, and let's choose the color from the background, make it maybe a little bit brighter. So we have some ambient lighting that spills light from there. So now we can maybe turn down the diffusion. So if we didn't have any diffusion at all, it's kind of receiving some ambient light from the background color. See, it's not that obvious, but if I was to put down some, like this is lighting it with some red orange ambient color, but or we can completely not have any ambient light and use the diffusion of our scene. This looks fine. Looks pretty cool. There. Plasticky, squishy, and this is not going to be quite obvious with the compression on YouTube with the tutorial video that I am doing now, but you can increase the multi-sample here, and putting that down to 16 will probably help a little bit, or setting it to super sample depending on what you're after. And we checked that Lumi light, so we're gonna create one, not an ambient this one, but let's create once again Control-Alt-Shift-L, and let's select this time a point light. Let's make it white, or maybe a little bit of heat in there, so a little bit. And our light is gonna be called TAO Lumi, all in caps, and this is changed a little bit. The aspect of it is going to be a little bit more precise of a light. It's going to make some glows, so that's pretty interesting. Also, you can play with that. Let's set that to the center to start with, and I'm going to reveal the layer controls. Control-Shift-H, and I'm just going to play around with it. Whoops! Make sure I move only the light object, and let's put it there, or try to create a little bit of backlight. It's exaggerated just to see where, and let's pull it further back so we can get some cool more custom highlight spot with that. And that's our TAO Lumi. Let's duplicate it. Now we have two lights on top of each other. Let's bring that so we can have more surrounding light, or even we can, instead of putting a positive value, we can get down to the negative, and that's what I like to do sometimes. And for this, if we put some color, it's gonna go reverse once again. So now we have some orange there. It's gonna make it a little bit of blue. So we're gonna try to keep it white, and that might also be for some other reason. But let's bring this, and let's pull it back towards us to really try to get more this shadow here, and toss it on the side there. So yeah, pretty neat. And then, as we often do, we can go right in the visibility here and set up some fog. So right now it's all crisp, all vibrant everywhere, but if we want to melt it a little bit with the background here, depending on any background color that we have, let's just pick it up here with the pick whip. I'm picking it up from the background color here, and let's find the distance of what we have. So this is the far. I'm just gonna drag this down until I find how far it is on Z. So there, I'm drawing it, but it's really like I'm going scanning through the Z channel until like at 1810 we're past our object here. So the fog N can end there, and the first value here must be something that is under that. So let's start around there. So right here we can bleed in some of the background there. It's a little bit smoother. So let's undo all that quickly. I'm gonna take a screenshot. Shift F8, Control Shift Z. I'm gonna go back to where I was there, and now I'm able to compare. So maybe I'm losing the highlights a little bit. It's getting, it's not the same. Maybe I want to bring a little bit more in. I don't want it all the way. I want it to be a little bit more subtle there. So something else to play around quite much there. And then another step that we can add to that is an overall adjustment layer. So in the end, finish with that. Control Alt Y is gonna add the adjustment layer, and let's get some levels. So level here, color correction levels. Let's add that to the adjustment layer, and let's go channel by channel. So this is the red, and let's look at our hills here, the kind of panoramic mountains we have here, and let's just bring our slider to better encompass this mountain here that we have, and look at the result that we get. So now that we've dragged this on the side here, we lose a bit of the reds, but look at the richness it might be, bring it to it. And let's drag that here, the mids. So let's do the same kind of pass on the green channel. Here it's all down, so it looks like we don't have anything to do in that area of the graph here. So let's try to bring them in, and sometimes it's not exactly turns out exactly as you would expect. Sometimes it's cool, sometimes it's not cool, but let's bring the blue as well. Try to see where we can get at. Maybe it's more, it looks more integrated all together when we add a pass like that over it on top. And let's also add a curves right to the last part of it, and maybe we can increase the contrast, so make it a little of an S curve there, or cancel a little bit of those darker colors here, flatten it out. Maybe that's something that you're aiming for, maybe not, I don't know. So this is this is where I wanted to get at today, and I don't think I have much more to say about knots. Yar! It's important to know how to tie some knots. Everybody learns that as a young Boy Scout, but making them digitally and using mathematics and expressions, it's always fun. I mean, if you like that kind of thing, if you like playing curling and not doing mathematics, well, what are you doing here listening to this tutorial? We're like 40 minutes through. Yeah, as always, thanks for watching, and see you next time.